life, just share it to both pieces. Who cares? Or however many pieces you've got. Good. Now let's look at the fun stuff. This is called long division. And even though I tease you about the fact that it could be hard, it's actually fun. Seriously. Here's the deal. The fact that everyone makes a face when I say something fun, I just don't know how to feel about this. Okay. It's fun for a math teacher. Okay. So, the idea with long division, you do have like some prep work to do. So let me write this, prep work. Before you start the problem, you're always going to want to write your powers. Remember how we talked about polynomials usually being in descending powers, the powers counting down? That's how you want to write them, both the quotient and the divisor. So both the thing you're going into when you divide and the one that's going in, both polynomials. So you want to write the pieces in order by power. In order with powers going down. And here's kind of the tricky part. If you're missing a power, you are missing a power. Put a placeholder there. And I'll show you what I mean by that in just a second. Sure. Very similar to how you do division. Not exactly. But you know what? It's similar enough that the way I usually teach this is by actually, once everybody gets this written down, we'll look at an old example of division to make sure we can all talk through it. Long division. Okay, the recording is going to make me sound like I'm some kind of crazy person who laughs in my whole class, because you guys are making me laugh so much tonight. Okay.
So we want to make it funny.
That's true, that does make it more fun. Okay. So let's recall something. Remember. Do you guys know why I have you recall things all the time, other than just because it makes it fun? There's actually research that if you're able to build a new idea on an old one, it makes it more permanent. You don't forget it. So whenever you're studying for classes, if you can make associations, even if they're funny little weird associations, it helps you remember the material. But that's why I do this. Gives you something to build on. So let's see. Now we've had a pedagogy lesson. You're welcome. I won't charge extra. Let's divide. How about 5 into that? And the idea is that just like with the last section, we're looking for patterns. That's our objective here. To see if there's a pattern in normal long division that we've learned before and what we're about to do tonight. So the first thing I'll usually say is, does 5 go into 2? No, okay, let's scoot over then. That's not something that will usually happen in this kind, but does 5 go into 25? How many times? Okay. This is the important part, guys. Everybody's eyes are on the screen absorbing content, right? Even Taylor's eyes are on the screen. I won't be me. Okay. So we said that 5 goes into 25 5 times, right? Then what do I do? 5 times 5 equals 25, okay? Then, what do I do here? Subtract. When I subtract, I get 0. Then, like Kel was saying, bring down the next piece. Then I say 5 goes into 0. How many times? 0. But then I talk back here, so after I put the 0 on top, I go back and say 0 times 5, right? I always take it back over. 0 times 5 gives me 0. Good. Then I put them together. What do I do here? Subtract, right? Get a 0. Bring down a 5. 5 goes into 5. 1 time. Then again, you multiply that through. 1 times 5 gives me 5. And I do what? Subtract. Now, if I had a remainder here, what would I have done with that? I don't have one. But okay, if I wanted to write it as a fraction, Jennifer, where would that number have gone over top of? The 5, the divisor? Okay. So if I had a number here as a remainder, I would have dealt with that by just putting it over that 5. So I would have had 5 over 1 and 1 over 5, for example, or 2 over 5, whatever that remainder was, right? Okay. This pattern, that's the pattern you're about to learn. I mean, that's kind of what makes it cool, is even though it's a pain, it follows such a neat pattern that it keeps it kind of interesting. So let me show you this. I'm going to tell you before I teach you this particular example, it is true that what we're about to learn after this method will take care of the easy ones like the one I'm about to do, but I want to show you on an easy one anyway. So this particular one you would not have to use long division on, but I want to take you through a super nice one first. So we have x plus 3, not 1, going into x squared plus 5x minus 7. And what I was saying a second ago about how certain ones will be easier, see how it's just a plain x and a plain plus 3 going in? That's the divisor, that's the piece going into the other part. Actually, when it's just a plain x like that, with plus or minus a number, like just 2 pieces and the x doesn't have a number in front, that's when we can use the special case I'm about to teach you in a minute, the synthetic. So you can make a note if you want. This can also be used for synthetic. But I'm going to teach you again long division. This is the way it works. The piece I keep taking in, because obviously I have 2 pieces on the left here going in. The piece I keep using is going to be that x right there. So I'm going to say x goes into x squared. How many times? X times what? Okay. Because remember, x to the first times x to the first equals x squared, right? I'll give you a second to digest that. You look at only the front. You don't look at the 3. You only look at the front piece. And of course, prerequisite stuff that I didn't even remind you guys of. It was already set up nice for us, but notice something. X squared underneath the bar leads to an x to the first to no x's. It's already in order, and all the powers count down. 2, 1, none, right? In front of the bar, we have an x to the first and then none. So it was already set up really pretty, right? Then all we do is take that first piece, the x, and take it into the first piece of the other one. Everybody okay? What's the next thing you do? Oh, so you take the x and you multiply it back to this. You also are going to go ahead and multiply it back to that one. That's when you care about the 3. So you say x times x gives me x squared. X times 3 gives me positive. Okay. Now what do I do? Okay. I'm going to change to green for a second. I've been missing the screen. It's too hard to get to. So if I'm subtracting this piece down here, that actually gives me a minus here and a minus here, right? When I'm doing the math. Because x squared minus x squared, that's going to cancel. What's a 5 minus a 3? There's a reason the green doesn't work well. Well, you know, I don't use it because it doesn't work very well, okay? So we take the first piece into the first piece here. X times what gives me x squared, so we said x. Just like over here, once you've got that number on 5, on top, you take it back and multiply it, right? Because 5 times 5 gives us 25. That's what you always would have done. I just told you to go ahead and hit every piece at that time on the way back through. So that's normal to multiply. That's a multiply right there. So then we have x squared and 3x. We know that at each step you're going to subtract. That's normal. That's what we always do in life. So I'm going to go and write above my things the minuses so I won't forget. When I'm using a pencil, what I do is I'll put like a minus in a little circle. and a minus in a little circle. So I know, so I won't get them mixed up. Am I actually minusing or plusing on each one? I'll have different colors, so I can clearly see it's a minus 3x. But if I didn't and I was using a pencil like you, I probably would have circled it so I'd see it really well when I write it on there. Okay, so now I'm going to say x goes into 2x. X times what gives me 2x? Okay, so now take it back. 2 times x gives me 2x. 2 times 3 gives me 6. And I'm going to do what again? Subtract everything. And that gives me a minus there and a minus there, right? So 2x minus 2x, that cancels. A negative 7 and a negative 6 gives me, gotta be careful. That's why I write that negative in front of both numbers, so I won't mess up and try to do the wrong operation. Okay, and we said when I have a remainder, what do I do with it? Negative 13 goes over top of x plus 3. So we're going to write the answer. X plus 2, this right here give me the answer, equal to x plus 2, negative 13 over x plus 3. Oh, don't worry. We'll make them more fun. This right here doesn't quite, do it for us. But you can. I'll give you so much homework that you won't even be able to go to bed. I'm just kidding. We're only learning one section. I know you guys are real life too, but I just can't see you. Okay. Let's do a harder one. Not much harder, but just hard enough to be a little more fun. Just slightly.
Let me ask one question before you get to that.
Yes, what's your question, Cal?
Like when you got down toward the end, you had like 2x minus 7, and then you were subtracting when you went back, and it was 2x.
Okay, so I did the minus here, and then I changed both these signs.
Why do you do that?
Because remember, when I have subtract, it distributes. It's in front of parentheses, so I share that subtract to both pieces. Because it was a minus in front of a 2x plus 6, and I had to share it. Oh yeah, you did. Because you're minusing that whole piece.
Well, yeah, I know that, but you try to make it minus.
That's fine. I would do it though. But I'm meticulous. I like to show why, so that's why I would do it. Yeah. Let's do more examples. I think you'll see it more. What we'll do is we'll have class until, what do you guys think, 9:30 tonight? Yeah, because I'm going to do that. I'm just kidding. So I told you guys I had an aerobics